It's done. We've done it. We've released ELEK Cable HV version 8.5. How do you feel?
Oh yes, Jason. It was hard work, but finally getting it through was a great achievement, I think.
We bit off a lot in this release. 12 major features, 400 total improvements. It was a lot of work. There was a big team around it, and you were leading that charge,
yes,
right?
we were, I think, four researchers working on it at the same time, and about 3 developers helping us, and you leading it all together. So that was massive work.
Yeah, so 12 major features. The primary feature was multiple circuits in a duct in FEM, right? So it's FEM, multiple circuits inside the same duct. We are modeling the convection inside the duct.
Yes.
And we can add circuits of any type inside the same duct.
Yes.
And we can move them around and change their arrangement, right?
Yes, depending on the field of the duct. If it's a solid field duct, then you can place it anywhere you want inside the duct.
Yeah. So that's part of FEM. And then we had a few other features added to FEM, right?
Yes, we added 2 more important features. One was solid drying out for FEM especially. So we are trying to see whether solid drying out, native solid drying out, is going to affect the cable ratings. And we have
How did we apply that? That was like some sort of function, right?
Yes, it was. So normally the IEC uses a step function. But we cannot use a step function because that's not reality. So we use another type of function to model that soil drying out.
Soil drying out. So in the FEM model, we're calculating temperature everywhere, and with that function, if the temperature exceeds a certain value, that function applies to the entire model, right?
It applies to the entire native soil model. So if anywhere the temperature crosses a barrier level, then the soil thermal resistivity also increases to match that
dry level. Yes. And then we do the FEM calc.
And then the FEM calculation goes on.
Load factor calculations, that wasn't so clear, right? We've added load factor, non-unity load factor to FEM as well, right?
Yes. This is an extension of our work. We did much research on this, and finally now we are applying FEM load factor even if they are in ducts, or if they are directly buried, we can apply load factor.
Now, I don't think anyone's done that yet, right?
Yes, it's an industry new. Probably we are the only ones who can do that in FEM.
Including in ducts. Yes. We did some validation of FEM as well, right? We validated our FEM calculations with CIGRE,
Yes, CIGRE had a technical brochure, TB 963, that came out very recently. So we were able to validate all the test cases in that, which is including multiple backfills, soil dry out. We had another technical brochure from which we validated the multiple casings. So that helped us a lot in that.
So we've got good validated FEM results. There were lots of guidance points as well on how to do FEM as part of that brochure, which we've applied some of those, right? Or most of those,
Yes, there are about 50 or 60 guidance points. We were able to achieve, I think, more than 70% of it. We will continue trying to see if those valid points can be implemented again in future releases.
But we still have great matching results.
Our results are all matching within I should say 1 ampere difference in all the test cases that we have done with TB 963, which we are already on our website also.
We did some major upgrades to HVDC calculations. Particularly, we'll see it in the cable model editor, right?
Yes, because TB 880 came out with an assumption that you should consider temperature drop across insulation for HVDC. But users were finding it difficult to get that value from. So now we are trying to help them to calculate that value from other parameters like electrical stress.
So you can enter an electrical stress limit for the XLP insulation. And then you can do the HVDC rating calculation. We did a lot of research, a lot of work on HVDC, right? Over many months. At least 6 months, and we've produced some great technical articles from that, webinars and papers from our knowledge about HVDC, Ampacity calculations. At the same time, for the HVDC cable database, we added 320 kV and 520 kV cable models to the database. We worked with industry experts to create those models. We go up to 3,500 millimeters squared, right?
Yes. And it's a first of its kind, I think.
Yeah.
No other software has such an extensive library now.
We have a massive library in our database of pre-modeled cables. Then the new number 5 here of the major features, new load factor calculator. This is quite a useful tool, right?
Yes. So now in this load factor calculator, you can go for any number of days or any number of years. If you can enter the data using an Excel sheet, and you can
import Excel sheets. You can calculate your actual load factor based on the load profile, right?
Load profile, yes. And then you can import it for the calculations and use it in the calculations.
Use it in the calculations, and then I think it goes into the report as well. Yeah, awesome. Non-isothermal ground surface. So already in FEM we already have that.
Yes.
But we've applied this additional calculation capability to the IEC buried, right?
Yes. So
what's the theory behind that?
So what happens is the air above the soil gets heated up, and we have to consider the convection. IEC doesn't do that. So we are extending the IEC method. We are considering a thicker layer of soil above that layer, and then modifying the IEC equations.
So we're adding this like hypothetical layer at the top, right?
At the top, yes.
And this gives us the ability to consider the convection.
Convection, yes. The width of that hypothetical layer is depending upon your air temperature.
So the new input for the IEC buried calcs is air temperature, not soil temperature.
Not soil temperature, it's air temperature.
Got it. Pause calculations. So we've always been very pleased that we have automatic calculations. You don't have to press the calculate button like traditional software and wait. Our calculations are almost instantaneous.
Right.
But the problem was when you have a lot of circuits, sometimes the calculations can take some time.
Yes.
So when you're making modifications to your model, it's auto-calculating and getting in the way of usability, right? So we, according to our users' demand, we now added the ability to pause the auto calculations temporarily, make your modifications, right? And then turn them back on if you need.
Yes.
So, I mean, we've been using that feature in the office. It's been pretty helpful, right?
Yeah, it's been a good development in the software, especially when you're working with very complicated arrangements and very custom arrangements. Then it's a very handy tool.
Number 8. So new buried circuit arrangements. We wanted to add some new functionality there so that you could specify the cable burial depth to be like the top of the cable, or the top of the duct, or center of the cable or circuit, right?
Yeah, center of the cable, center of the duct. We could specify spacing in terms of cable diameter or in meters. In terms of ducts or cables. So all those arrangements.
So we can also rotate, permutate the phases, right? So we've added some more functionality like that. We've cleaned up the user experience, the user interface. It's a lot nicer to look at and use.
Easier,
So that's what we did there. Standing voltages and current upgrades. This was an interesting one. We upgraded the Sheath standing voltage calculations. You in particular and your group. What did we do there?
So again, it was a customer request that they wanted to know the effect of in-service circuits on out-of-service circuits. So that was the request. But to do that request, we had to go into the Sheath standing voltage calculations and see how they work, bring it into per cable levels, and then display all the results.
So now our results for Sheath standing voltage and circulating currents are all on a per cable basis. And so those results are there.
And then we also extended the calculations for circulating current when there's an unbalanced cross-bonded system. So that was included in the report.
So we're now calculating and displaying those currents and voltages for cross-bonded unbalanced systems, right? And then number 10, out of service circuits. So that came at the same time.
Yeah.
When we were building that feature for this customer,
yes,
we decided that we needed to add this out of service feature, right?
Yes. So we added the out of service feature. So you could take any number of circuits out of service and see the effects of the other circuits onto them.
Yeah, even though they're carrying no current.
There is no current.
Yeah, got it. So that's 9 and 10. Import buried installation. So this goes way back, and we've built a tool where you can transfer installations between FEM and any buried installation.
Yes, correct. Yeah. So the ability is, if you already have an installation in the buried module, you want to see what is in the FEM, so you can just transfer it. You have the ability to retain other circuits which are in the module. Or you can delete the other circuits.
So if you've done a calculation in the buried, like IEC calculation, and then you want to see what's the rating in FEM, you can easily transfer that model into FEM.
Yes.
And vice versa, actually.
Yes, vice versa. Yes.
And you can choose what you want to transfer.
Yes.
And what you want to keep.
Yes. For example, in FEM you can have multiple backfills, but if you go to the IEC methods, you can have only one backfill. So now we give you the ability to choose which backfill of the two you want to import.
Got it. Undo function. I mean,
massive.
Really important function in any software, right? Not that easy to achieve when you're building complicated software, right? We have lots of modules and pop-ups, and the software is really quite complicated and made up of a lot of blocks, right? Now, when you press Ctrl-Z, just like in other software, we can undo what you've done.
We can undo anything that you changed. Even deleting circuits, if you undo it, you can bring it back. So all functions are undo.
So we've got undo and redo. And up to 20
undo redo functions.
Awesome.
Which is a massive thing.
Instant congratulations.
Thank you.
Congratulations to our team. Thank you to the customers for your feedback. We're looking forward to more feedback so we can build more amazing features into our products for you. It's been a great journey, and we are continuing with more.
In the next releases.
In the next release, right?
Yes. More features.
Look forward to it.
Look forward to it. Thank you, Jason.
Thanks so much, Instant. Well done.
Thank you.